Okay, all ready for this last fun video? Had to do a little bit of change of scenery. Way too hot outside. Okay, so last thing we're going to do, again, a lot of this is kind of common sense, but some of these can be worded a little strangely. So now we're going to be taking all the things we know about probability, theoretical probability, and applying it to geometry. We're going to be talking about segments and lengths, and then also area. All right, so grab your calculator, grab your puppy dogs, and let's get started. You ready? Okay. So basically, geometric probability is simply taking part out of the whole. So I'm not going to focus on a fancy definition or anything like that, because I'm just going to dive right into examples. It's pretty simple. You take the part that the event of the probability, that's your part, divided by the whole length or whole area. So for segments, let's look at example 7 is what we're on. Point Q, that should say, sorry, point Q lies on AE. Wait, point Q on, no, that's not right. Okay, whatever, it's right. Point Q is on AE and it's chosen at random. So I'm going to highlight AE. This is the entire segment. So that's going to be my whole. It says, what's the probability that Q lies on AD? So now let's look at AD. That's going to be my part. So we're going to take the segment for AD, which is the part, and then you just you can count or you can subtract, right? That's 7 minus 4, or you can just count. That's 3 units. And we're going to put that over my whole, which is AE, the whole segment. And again, you can count or you can subtract. 8 minus 4 is 4, right? So pretty simple solution there. 3 over 4 is my answer, or 75%, or 0.75. Okay, so not too bad with the segments. You just take the part, right up here. You take part, and then you divide by your whole. That's it. Okay, now let's apply that to, instead of segments, to area, okay, that you have been doing from Unit 7. Sorry, that was Alexa. All right. No, Alexa, be quiet. Okay. Anyway, okay, so this one's fun and should look familiar. This is actually going back to the circles unit. So you might want to pull up your Pearson as we go through this, because there's definitely an example like this on there. So it says a point on the figure is chosen at random. So when I say the figure, I mean the entire circle. So your whole thing is going to be, I guess I have this reversed. This is your whole figure, is the circle. Okay, so that's all of this. What is the probability that this point that's chosen at random lies in the shaded region? So we have this shaded region, which is going to be our part. So again, part over whole. Okay, so that means when we're talking about area, we're going to have to find the area of the sector, that's called a sector, if you remember, and divide by the entire area of the circle. Okay, so the area of the circle is pretty straightforward. The formula for the area of a circle is pi r squared. The formula for the area of a sector, you have to go all the way back to whatever the circle's unit is, unit 6, and it is theta over 360 times pi r squared. Okay? Okay, interesting. So, you might notice what's going to happen here, okay? But we're still going to practice doing all of this, all right? So, the theta is your degree, 100. So, we do 100 divided by 360. Multiply that by pi times 4 squared. Okay, you can just watch for now because you might see what's going to happen. All divided by pi 4 squared. Interesting. Do you see what's on the numerator and the denominator? 4 squared, pi, pi. So guess what's going to happen with those? Boom, they're going to cancel each other out. And so what are you left with? 100 divided by 360. And so then you just simplify that, right? That's going to be 10 over 36, which is 5 over 18, or whatever that is as a decimal. So really, when you're doing these problems with sectors, all you have to do is your theta divided by 360, and that's going to be your probability of the event, where the event is landing in the shaded region. So that one's actually a lot easier than it seems. Okay? Okay, let's do another circles one. It says a point on the figure is chosen at random. What is the probability that it lies in the shaded region? So again, if you want to do part over whole, that's going to be shaded over the whole thing, right? So the highlighted or shaded portion here. So, you probably need dimensions here. So let me give you some dimensions here. Let's say that this entire radius here is 20. And let's say that from here to here, it's 5. That little piece right there is 5. So what we want to find is we want to find the area of the entire thing, the whole thing, which is pi r squared. So when I say 20, sorry, I didn't really specify that. Let me go back. The 20 is referring to this whole radius. So the entire area of the circle is pi r squared, where your r is going to be that whole big radius. Now, what's tricky though is on the top, to get the shaded region, you have to subtract. So this is back with the area. So for the shaded region, you actually have to take the whole area, pi r squared, which is pi 20 squared, and you have to subtract the area of the non-shaded. Okay, here, let me write this out in general. Okay, so we want area of the whole minus area of the non-shaded, and this is area of the whole, just so you can apply it to your homework. That says non-shaded. Okay, so again, that's pi 20 squared on the bottom, pi 20 squared on the top here, but then minus the non-shaded. So I'm going to highlight the non-shaded. So now this is my non-shaded. Well, that means I need the radius for that portion. So 20 minus 5 is 15. So the non-shaded is a circle with a radius of 15. So we're going to do pi 15 squared. Be careful because these right here do not cancel each other out because of this subtraction sign. So don't cancel those out. Okay. Okay, let's do that. So we're going to have 400 pi minus 225 pi all over 400 pi. So you want to go ahead and subtract 400 minus 225 to get 175 pi over 400 pi. You'll notice the pi's will cancel, so it's just 175 divided by 400. And so you can either simplify that, which would be 7 out of 16, or you can write this as a decimal, which would be 0.4375. Okay, depending on what you want to round to, you might want to round that. Okay, so that was kind of complicated. If you're struggling with it on your homework, just come back to it and come see me during our Microsoft Teams meeting, and I can do that with you. Okay, one more. Woo! Ready? Okay, this one's not too bad. We're going back to segments now. It says points X and Y are on AB with X between A and Y. Let's say what now? Draw a picture. When in doubt, draw it out. So we're going to draw AB. A, B, because that's my whole segment. Okay, that's the whole. Keep that in mind. Somewhere between A and B are points X and Y, with X between A and Y. So that means if this is Y, X has to be somewhere here between A and Y. AX is 15. YB is 11. And AB is 32. A point on AB is chosen at random. What's the probability that the point is on X, Y? So the probability that you get a point on X, Y, I'm going to highlight X, Y. So what I need for that is I need the length of X, Y divided by the whole length of AB. Easy peasy. So then you have to figure that out, right? So 15 plus 11 is 26. But then I need to subtract from the total 32. So 32 minus 26 is going to be 6. So that means right here, XY has a length of 6. So 6 divided by the whole thing, which is 32, and then simplify. So that'd be 3 over 16, or if you wanted to write that as a decimal, 0.1875, whichever one you prefer. Ta-da! Move that up a bit. Okay, so that's it for this lesson. I hope you enjoyed and stayed with me the whole time. I also hope that you enjoy this new change where I am not going to give you quizzes over each lesson anymore. I just want you guys to learn it. I don't want you to stress about, what if I don't do well on this 5-question quiz and then I get a 60 and then I have to retake and I only can get a 70 and my grade's going to go down. I feel like you guys are stressing over that aspect a lot, and so I really just want you to take this time to try to absorb and learn as much as you can, which is going to be going through and doing these practice problems on the homework. And if there's anything you don't understand, please come see me. And like I said in my post and email to you, you will have a test over probability on GradeCam, and it's going to cover all of these topics, but then that way it's only that one grade, and all of your homework grades, you should be hopefully getting hundreds or at least high A's and B's on the homeworks, so you can have good grades. But again, just try to focus on learning the information, okay, and trying not to stress yourself out too much. I know it's hard, but yeah, come see me in my Teams if you have any questions. You're beautiful and you're wonderful, and I miss your faces. Mwah! Let me know if you have questions. Bye, guys.